Welcome to section 8 for debugging concepts and techniques. Writing code is only half the story. The other half is figuring out why it doesn't work the way you expected. That's where debugging comes in. By the end of this lesson, you'll know how to test and debug your Java programs effectively, identify the 3 types of errors, use tools like print statements and your IDE's debugger, and apply some proven debugging types. Let's start with the story. Richie wrote a simple program to find the maximum of 3 integers. It worked fine with several test cases like 359, 1216, but someone told him it didn't work, and he couldn't figure it out why. Here is the code on this slide. The program is tested on many sets of data. However, the program doesn't work as intended. How can we figure the problem? In the exercise 1, open the maxintegers.java file. Try running it with duplicate values like 333 or 727. What do you notice? The answer is it outputs 0. And that's not right. So what's wrong? Richie didn't account for equal values. If no single number is strictly greater than the others, none of the if statements run, and max stays 0. Let's fix it with a better approach. Int max assign num1. If num2 greater than max, max assign num2. If num3 greater than max, max assign num3. Now it works for duplicates also. This leads to an important point: testing and debugging. Testing is checking if your code works. Debugging is figuring out why it doesn't when it doesn't. They go hand in hand in every project. There are 3 main types of errors in Java. The first one is compilation error, also known as syntax errors. The other one is logic errors. The third one is runtime errors. Compilation errors, also known as syntax errors, they're usually caused by typos or missing symbols. The logic errors, the program runs but produces the wrong result. For instance, using an uninitialized variable. Runtime errors, they crash the program during execution. Examples: division by 0, accessing a bad array index. In Java's exception handling, like try-catch, it helps catch many runtime errors. But your best bet is to find bugs early with testing and good debugging. What techniques can you use to debug? Use print statements or use the IDE debugger. The first tool is old school but still gold: print statements. The advantage is it's easy to add. It shows you what's happening, like values or method calls flow. The disadvantage is it can get messy very fast, not scalable for large programs, and tedious to remove afterwards. This example looks fine, but it is wrong. Try printing each value at every step. You'll see the bug. Initializing sum to 10 makes it double count 10. The next tool is your IDE debugger. You've likely used breakpoints and step-by-step execution. Let's add one more: the variables window. In NetBeans, you go to Window, then Debugging, then Variables. When a breakpoint is hit, it shows current values of all variables. No need for print statements. In exercise 2, open the ComputeTime.java project. The program calculates time using distance equals SQRT, then time equals distance divided by speed. Step into the getDistance method and watch the values. Can you spot the bug? Observe the value of distance. Here's the bug: math.sqrt in parentheses, then again in parentheses x1 minus x1 times in parentheses x1 minus x2 plus in parentheses y1 minus y2 times, in parentheses, y1 minus y2. x1 minus x1 is always 0. So distance is always wrong. Since we have found the bug, let's fix it in the code. Fix it to math.square root, in parentheses, again in parentheses, x1 minus x2 times, in parentheses, x1 minus x2 plus, in parentheses, y1 minus y2 times, in parentheses, y1 minus y2. Now you'll see correct values in the debugger. Let's go over some common mistakes. Confusing single equal sign for assignment and double equal sign for comparison. Misplaced semicolons. Watch this, they are very sneaky. Another one, wrong method arguments. If a method expects integer and char, don't call with string and boolean. Always match the types in the order. Now let's talk about boundary conditions. The edges of what your input allows. These are common places for bugs, so test just below and just above limits. In this example, 49, 50, 51. The beginning and end of loops. The minimum and maximum valid values. In the exercise 3, add boundary testing.java to your project and test inputs like year 1582, 1583, and month 0, 1, 12, 13. These push the edges of valid input and help catch logic errors. To wrap it up, you've now got the tools to test your programs thoroughly, spot syntax, logic, and runtime errors, use print statements and debuggers to track bugs down, apply smart techniques like boundary testing, and avoid classic gotchas like double equal sign versus single equal sign or misplaced semicolons.